All right, so another quick mini lesson. This is actually more of a review because you guys have seen special right triangles. We are going to be relying on our knowledge of special right triangles. So we're going to review it really quick. I'm going to do a couple of examples and then ask you guys to finish this worksheet together in class and then turn it in before you leave. So special right triangles, there are two of them, 30, 60, 90 and 45, 45, 90. The 30, 60, 90 triangle is what it is an equilateral triangle. So a triangle where all three sides are exactly the same, cut in half. So the 30, 60, 90 relationship, I'm going to erase this for now, but I'll probably redraw it in a little bit just to remind you. The relationship between these sides, you may have heard me use the rhyming scheme, one tree, two tree, tree root three. So the shortest side is always the one tree. So, and I use the variable t for tree. The longest side, actually, I will redraw this. If this was an equilateral triangle that was cut in half, then t, obviously, this, if I was talking about the whole base, that would be 2t. So all sides of this equilateral triangle having the same length would mean this was 2t and this is 2t. So the longest side, if I'm ignoring that, the longest side here is, the short side is t, the longer side is 2t, and you can visualize the hypotenuse being that other side. And then the tree root 3 or t root 3 is the length or the height here, which we could just solve for using the Pythagorean theorem. So again, it's one tree, two tree, tree root 3. The shortest side is always the shortest multiple of t, which is 1t. The longest side, the hypotenuse, is 2t, and the other one is t root 3. 45, 45, 90 triangles, you can kind of imagine as just a square cut in half. So a square, and all four sides of a square are the same, obviously. So I use the letter B for boo because of the silly rhyming scheme here. If these are both B, we could use the quadratic formula, or not quadratic, Pythagorean theorem to solve for this, which would be boo root 2, or the square root of, or B times the square root of 2. The rhyming scheme is boo, boo, boo root 2. Again, you could think of it as these two sides of a square with a diagonal and use the Pythagorean theorem. Memorizing these relationships will be super useful. So what I want you guys to do is use these facts to figure out the missing sides of all of these triangles on the page. I'm going to do a couple of 45, 45, 90 examples with you, and then a couple 30, 60, 90, and then have you guys finish. So this first one, 45, 45, 90 triangles are great because if you know one leg of the triangle, so the hypotenuse again is opposite of that right angle. If you know one leg, you automatically know the other leg. So the value of B is obviously 2 root 2 because, again, think of it as pieces of those two sides of that square. And then the boo root 2 piece would be A, but think about what the boo is, or the B value, which is 2 root 2. So 2 root 2, 2 root 2. So A would be 2 root 2 times the square root of 2. So that B also has a square root in it. So A would be the 2 root 2. So that's just whatever that B value is, times the square root of 2. So it looks kind of funky because we have 2 times the square root of 2 times the square root of 2. So now we just need to simplify that. Well, the square root of 2 times the square root of 2, remember, that's just the square root of 2 squared, which is just 2. So this ends up being 2 times 2. So A equals 4. So this is what I'm asking you to do. I want to see A equals blank or X equals blank. Circle it so I can see your answers clearly. And then let's see, I want to do one more and try and simplify it with you. I think I will do number 2 with you guys, even though you'll probably, actually, I'm going to let you do number 2 by yourself. I'll do number 3 with you. Okay. So again, another 45, 45, 90. No, we'll do 6 because 3 is similar where you have the 2 legs. 6, we know the hypotenuse. So let's work on that one. All right, so again, this is like our B, and this is our B root 2. So the two sides of the square are identical, and then this would be the B root 2. So we know basically that this value, this numerical value, 2 root 6, equals these b's, one of them times the square root of 2. So you would actually write that out. We know that the boo root 2 piece of this 45, 45, 90 equals 2 times the square root of 6. So I just want to figure out what is the value of b. What are the values of these individual sides? So you just solve for it. So I know that the boo root 2 side equals 2 root 6. To solve for b, you would divide by the square root of 2. Okay, now the only problem here is that we don't want, so that root 2 over root 2 cancels, and we just end up with 2 root 6 over root 2. We don't want square roots in the denominator of a fraction. So the last step would be to rationalize that denominator. To do that, you multiply top and bottom by whatever is in the denominator that you need to rationalize. So we're just multiplying by root 2 over root 2. So we're not changing the value because really we're just multiplying by 1. Now we get 2. Now when you multiply roots, you've got root 6 times root 2. So that's actually, you can multiply those together and get square root of 12. And then 2 square root of 2 times the square root of 2 is just 2. And now we've got 2 root 12 over 2. So a couple more steps left. The 2 over 2 cancels, but we also need to simplify the square root of 12. So you guys have been practicing stuff like this. I'm going to rewrite 12 as 4 times 3. And that breaks down how I can take the square root of 12. So the square root of 4 is 2. And then that just leaves that in there. So that equals x and y because x and y are identical there. Okay, so that's one example for 45, 45, 90s, or 2 examples. And then for 30, 60, 90, a couple of examples here. So look at number 7. We have the hypotenuse already. Again, the short side of a 30, 60, 90 is the 1 tree. The long side is the double of that. So right away, if 16 is double of the short side, I right away know that t or y has to be half of that. So y equals 8. So my t is 8. So 8, 2 times 8, and then 8 root 3. 1 tree, 2 tree root 3. So x is just 8 times the square root of 3. Okay, this should be enough to get you guys going on this. I would like you to, during class time, finish this worksheet. Please circle all of your answers so I can easily find them. There is a back, you're gonna do that. And you're gonna end with this last one on the back. Determine the lengths of the following triangles if they have a hypotenuse of 1. I want to know if this hypotenuse is 1. Why don't we just go ahead and label these right now? We'll label them x and y. I want you to tell me what x equals. I want you to tell me what y equals. If this 45, 45, 90 has a hypotenuse 1, I want you to tell me what those 2 values are as well. So finish this, circle your answers, show me your work, and then turn this into the black tray. And then you can go, and your homework is the 9.1.3 review and preview. Okay. All right, y'all. Thanks. See you soon.